Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to another video for all my grade 9 elite math students who are going to give the exam very shortly on 12th of June. So today's video is specially on your demand, on your request, where we cover part 3, learning objective 21. So remember, part 3 of the exam is going to be pen and paper based. So in today's video, I'm going to show you all the steps for the questions which are based on learning objective 21. So let's get started with the video. So in today's revision session, we are going to focus on part 3, that is learning objective 21, 22, 23, and see how we can use the addition rule to situations involving events that are not mutually exclusive. We are going to cover 25 to 30 questions on your math book, page 412. Then we are going to move forward with learning objective 22 and sketch the graphs of function by using their key features. So here we are going to cover questions 1 to 8 given in your math book on page 463. And finally, towards the end of the session, we are going to focus on piecewise functions and we will write their equations and graph them. So we are going to cover question 21 to 32 given in your math book on page 481. So let's start with the session and see the first question for today. So the first question that I'm taking in today's session is question 26, which focuses on learning objective 21. So here, if you see carefully, there are two boys, Theo and Mason, and they want to determine the probability that a red marble will be chosen out of a bag. And what all is there in the bag? Let's draw a rough figure and it'll be easy for us. So there are 4 red. So I denote 4 and a capital R to denote the red. 7 blue, so 7B, and 5 green, so 5G, and 2 purple, so 2P. Now let's add them up so that we get the total. So in all there are total 18 marbles in this bag. Okay. Now, both of them have found a different value for the probability. Theo has found it to be 4 divided by 17 and Mason has found it to be 1 minus 4 by 18. You have to tell who is correct and why. Give reason. Okay. So, if you see, we have to find the probability of a red marble. That means the probability of red marble, if you know the formula for probability, it is favorable outcomes divided by total outcomes. This is the formula. So what are the favorable outcomes to getting a red marble over the total? So how many red are there? Let's go back to the figure. So there are 4 red marbles. So definitely favorable is 4 because any one out of the 4 red marble can come. And total outcome is 18. So 4 divided by 18. This is going to be the correct answer. Now, if you look at what these boys have done, Theo has done the total wrong and he has calculated 4 divided by 17. So definitely Theo is wrong. Let's look at Mason. Mason has done 1 minus this. That means he has taken a complement. So this is actually what Mason has found is the probability of not a red marble. So this is also wrong because you have to find in the question probability that the red marble will be chosen. Okay, so both of them are wrong. And I know and I hope that you understood why both of them are wrong. Yeah, because the correct answer is going to be 4 over 18, 4 divided by 18, which none of the boys, Steve or Mason, has found. So that completes this question where you have to find the error. So now I'm going to show you the correct answers for learning objective 21, question 25 and 26. So as we have already discussed, in question 26, neither of them is correct because the probability that the red marble will be chosen is 4 over 18, which none of them have got. Okay. In the next question, which is based on learning objective 21, again, we have to use the concept of mutually exclusive events. I want to remind you here that mutually exclusive events are the events that cannot happen together and hence they don't have any common outcome. So there are 3 parts given here, question 27, 28, 29. For each of these parts, we have to check whether they are mutually exclusive, yes or no, and give the reason. Okay, so let's do 27 first. Choose a quadrilateral that is a square This is the first event, so I'm just highlighting. So this is event A, and the second event is choose a quadrilateral that is a rectangle. So two events are there, A and B. Now I want you to think, are these mutually exclusive or not? That is, do they have any common outcome? Now a quadrilateral, that is a square. Can it be a rectangle also? Definitely yes. And the reason is because all squares are rectangles, but all rectangles are not square. So therefore, both of these events A and B do have common outcome. Okay, so I can write like this: events A and B have common outcomes. Okay, what is the common outcome? Because a quadrilateral, that is a square, can also be a rectangle. Yeah, so I will write here quadrilateral can be both a square or a rectangle. So therefore they have common outcomes. And if they have common outcomes, they cannot be mutually exclusive. So the answer for this question is not mutually exclusive, as they have common outcomes. Also remember, all squares are rectangle, but not all rectangles are square. So that is another reason, another way of putting the answer. Now, the part that we are discussing in today's session is part 3. So this is pen and paper based. So you have to show your steps, you have to write the steps. So there can be a different way of writing the same answer, but then you should include all important points. Let's do question 28 now. So here you have to choose a rectangle, sorry, choose a triangle that is equilateral and a triangle that is an equiangular. So a triangle that is an equilateral means that's event A, and a triangle that is equiangular, that is event B. Okay, so are they mutually exclusive or not? Definitely this is also not mutually exclusive. And what is the reason? As a triangle, this is the way I denote a triangle, can be both equilateral and it can be equiangular also. So just remember, equilateral means all sides are equal and equiangular means all angles are equal. So remember, if a triangle is equilateral, means all the sides are equal, so all their angles are also equal, because all angle will be 60 degree. So definitely this is not mutually exclusive. Next one, last one, choosing a complex number and choosing a natural number. So what is a complex number? A complex number is a number which has a real part, so like a number, and an imaginary part. So this is the formula or the form of a complex number. And a natural number, you all know, natural number is denoted by n. It can be like 1, 2, 3, 4, so on. These natural numbers. Now, I can write a natural number in the form of a complex number also. How? Because a natural number can be written as n plus 0 I. So it does not have any imaginary part, only real part. So because every natural number can be written as a complex number, again they have common outcomes. And because they have common outcomes, they cannot be mutually exclusive. So for question 29 also, the answer is not mutually exclusive. So I hope you've understood question 27 to 29, which is based on mutually exclusive events. So now you can check your correct answers, and as I've already told you, there can be more than one way of expressing your answer in sentence form. So when you write it in your part 3 on the paper, make sure you are just including the important keywords. Okay. So let's now finish the last question based on this learning objective 21. So here you need to explain why the sum of the probabilities of two mutually exclusive events is not always 1. So I want you to recall, if we have a mutually exclusive event, by definition, it cannot happen together. So both the events A and B, which are mutually exclusive, they cannot happen together. But that does not mean that one or the other of the events must happen. Okay, so this is something you have to remember. So the sum of all possible outcomes in a sample space must be 1. Remember, the probability of an event E always lies between 0 to 1. So at the maximum it can be 1, or it can be less than 1, but it cannot exceed 1. So it must be 1. So for example, if you have two events A and B and they are given to be mutually exclusive, the sample space is going to include the probability of the first event A, the probability of the second event, and it will also include the probability of none of the events A or B happening. So all of this has to come out to sum of 1. So the maximum probability, as I just told you, is 1. So when you add all of these three probabilities, the sum is 1. So therefore, the sum of the probabilities of event A and event B may be 1, but not necessarily. Definitely, it has to be either less or equal to 1. So this is the last question in this video on learning objective 21. Thank you for watching. That brings us to the end of today's session. I hope you found the video useful, and if you did, give it a thumbs up, like, share and subscribe to my channel. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye bye.